Hello everyone, welcome to the video series of XCAN, and today we will learn about the Rust programming language. As so far we have understood about what is smart contract, the use cases of smart contract, and then we have gone through what is stylus and wasm that is used in Arbitrum stylus tech stack. So now we will go through the Rust programming language which you can use to write your smart contracts. So this is the introduction to Rust, like what we will be covering. So first of all, we will be going through why Rust, installation of Rust, and then we will be going through the syntax of the Rust, variable and data types, and then we will be deep diving into the core concepts of Rust like ownership, borrowing, shadowing, referencing, immutable and mutable referencing, and moving in Rust. Yeah, so before learning any programming language, this is the first question which should come in anyone's mind. Like, why do we need that particular programming language? So, yeah, why do we need Rust? So, basically, these are some points which justifies why do we need Rust. So, the first point is memory safety without the garbage collector. So, if you are familiar with the programming language like Java, then you might heard of this term called garbage collector. So what garbage collector does, it periodically checks the unused memory held by any variable and clears that memory periodically. So garbage collector automatically does this job on behalf of user. So user don't have to do anything. But if you are coming from C or C++ background, then you have to do this by yourself using the functions called free, right? But Rust manages memory differently using the ownership model. So we will walk you through that also. So this is the first point, memory safety without garbage collector. Second point is blazing fast performance. So Rust uses wasm. Rust compiles to highly optimized machine code. So due to it, it provides blazing fast performance, and it can be used for low-level tasks like operating system design, IoT, blockchain applications, web browser design, and this all low level of task can be done by Rust. Then third point is strong type and error handling are providing. So the third point is strong type system and error handling has been provided by Rust and the great developer experience. So these are all some points for the answer of why do we need Rust. Moving forward, so this is the installation guide. For Windows user, you can run this command, and Linux or Mac OS user can use this command. And after running this command on your system, you have to run this command to check that Rust has been installed successfully on your device. Yeah, so basically this is the structure of the Rust where you will have the main.rs file which will act as entry point of your project, just like index.js but main.ts. So if you are familiar with Node.js, you will get an idea of this index.js, which is the starting point of any Node.js project. Yeah, and second files is cargo.toml and cargo.log. Toml stands for Tom's Obvious Minimal Language, which is similar to packet.json, and cargo.log similar to package-log.json or yarn.log. Let me walk you through this. So as you can see, this is the main.rs file which acts as an entry point of the program, and this is the cargo.toml file where your all dependencies will be installed, and the information of all the dependencies used by your project will be stated here with minor, major and patch version of the dependencies, and this is the cargo.log file similar to package-log.json or yarn.log file which you have in Node.js project, right? And yeah, Rust is a static programming language. What do I mean by static programming language? So static programming language means at the compile time you have to pass the type of that variable. So if you are coming from the JavaScript background, then it is a dynamically typed programming language where you can, if it's fine if you don't define a type of variable. For example, if you are defining a variable using a let keyword, then you can assign string or integer value to that variable. But in Rust, we have to define the type of the variable at the compile time only, right? So that's why Rust is static programming language. So first you have to compile the Rust program. For example, here I have written a simple hello world program where fn is a function So declare any function, fn keyword is used. Main is the entry point of the function, and println exclamation mark and hello world is used to print the syntax. Exclamation mark stands for macros. Macros are used to print anything on the console. So you first have to compile the contract, compile the Rust program, and once you have compiled, main will be generated. So if you write the command ls, then you can see that a main is generated. So now you can run this main to run your code, and as you can see that hello world has been printed. So this is like just another programming languages like C, C++ or Java, where you first have to compile your code and then you can run that build file, right? But it is different from the dynamic programming languages like JavaScript, in which you can directly run your code. But here first you have to compile your program. So we have understood this folder structure, right? So now moving forward. Yeah, so getting started with Rust. So as I said earlier, Rust is a compiled language and it is not a dynamic language like JavaScript. So this is how you are defining your logic in the integer main function in the C languages, and same how we also have a driver function called public static void main in the Java, where we are defining our all logic inside the driver method. So in the same way we have the main method in which we have to define our all logic in the Rust programming language and to declare a function. So for the function declaration, fn keyword is used, and to print anything on the console, print exclamation mark. This syntax has been used here. Exclamation marks stands for the macros. So macros are used to print anything on the consoles. So yeah. Moving forward, memory management in Rust. So as we have seen that in Java we have the garbage collector, which periodically checks for the unused memory held by any variable, and it will free that memory on behalf of user. So memory management will done by garbage collector. So you can't do manual memory management in programming languages like Java or JavaScript, but in C or C++ programming languages, where you have to allocate and deallocate memory by yourself. So memory management is up to you. But if you are managing the memory, then there could be possible chances that you will fall into the memory null pointer or dangling pointer issues. So the Rust has its own ownership model for the memory management, and that makes it extremely safe for the memory errors. And that's why Rust has been used to low level tasks like system design and operating system, web browser, and kernel designing. Okay, moving forward. Okay, variables and mutability. So make sure that everything in Rust is by default immutable. You can't change the value once you have assigned the value to any variable. If you want to change the value of that variable, then you have to use mute keyword. So as you can see, I have declared one variable called x, given the value 5 to it, but it is immutable. You can't change the value of 5 to x variable. And I have again declared another variable called y, assigned value 10 to it, and now here I have changed the value from 10 to 15 for that y variable. Here it is allowed it. Why? Because here we have used mute keyword. So if you are using the mute keyword, then you can change the value of that particular variable. And then we have, if you are trying this syntax in programming languages like JavaScript, then you will get an error, because you cannot redefine or redeclare the same variable in the same scope again, right? In the same scope, then you will get an error. But in Rust, if you are declaring a variable called z is equal to 5, and then if you are redeclaring the same variable in the same scope with the same name called z is equal to z plus 1, then 5 value will be passed to here. 5 plus 1 is 6, and this syntax won't give you an error. This is called shadowing. So variables are immutable by default. You have to use mute to allow mutation, and shadowing allows reusing the variable names for transformations. Moving forward. Okay, scalar and compound data types. So Rust basically have two types of data types, scalar and compound data types. Scalar has four primary scalar types: integer, float, boolean, and character. Integer have also two types: signed integer and unsigned integer. U means unsigned integer. Unsigned integer means value from only positive value, 0 to onwards. Here U8, so 8 represents a bit value, means 8-bit number. So here we have two formulas by which we can calculate till how long we can have a number assigned to any particular data type. For example, for the positive number, we have the formula 2 raised to the power n minus 1. N stands for number of bits. For example, U8 means unsigned integer 8. So 8 means 2 raised to the power 8 means 256 minus 1 means 256 minus 1 is 255 means 0 to 2 to the power n minus 1 means 0 to 255 means you can store 0 to 255 numbers in U8 data type. If you are trying to pass any negative value or any other value from the boundary 0 to 255, then you will get an error because U8 can only have number range from 0 to 255. And for the negative value like I32 and I64, we have the formula minus 2 to the power n minus 1 to 2 raised to the power n minus 1 minus 1. Okay, so float stands for decimal point like F32 and F64. Like if we have decimal number like 6.5 and 6.8, like that kind of number can be used using floats. Booleans have true or false value, characters have Unicode characters, and then comes compound data types. So compound data types have a tuple, array, and vectors. So make sure that in Rust programming language, array cannot grow. So in another programming language like C, C++ or JavaScript, if you are defining an array and trying to push or pop element from to array, then it is allowed it, right? But in Rust, it is not possible to increase or decrease the size of the array once it is defined. And if you want to do that, then you have to declare a vector. So vector stands for growable array. So let's look into the array tuple first. So tuple is just like a struct in other programming languages, where you can combine the multiple types of data types stored into one single variable. For example, 42 is a type of I32, 6.4 is of type F64, and R is of type character. It is all three has been stored to a tuple data type. So moving forward to vector. So for example, if we have declared a vector here and then we are pushing the value 10 and 20 to it, then we are printing the vector and it will give us output 10 and 20. So just because we have used the mute keyword, that's why we are able to push 10 and 20 to vector. Why? Because I told that everything in Rust is by default immutable. So if you want to change the vector and want to add or remove any value to vector, then also you have to use mute keyword. Okay, so moving forward, struct in Rust versus JavaScript class. So basically we have this keyword in JavaScript. So same way we have self keyword in Rust. So let me explain you both of that. So for example, this is the code of JavaScript where I have declared one class called rectangle. This is the constructor to set the width and height of that rectangle using this keyword, and this is the area method for that rectangle class, which calculates the area by multiplying the width and height of the rectangle. So so as you can see, I have instantiated one rect1 object from this class called rect1, and I have passed this 10 and 20 value to it. So here 10 and 20 has been passed here, so width has been set to 10 and height has been set to 20. So now if I am calling the area method, so area method has this dot width. Now what is the meaning of this? This means this reference to the object on which the method has been called, means this reference to the current object on which this method has been called of, means area method has been called on which object? rect1. So means rect1 dot width multiplied by rect1 dot height. So means, let me explain you again, this reference to the object on which the method area has been called. So method area has been called to rect1. So rect1 has been passed to here, means rect1 dot width and rect1 dot height, right? So means 10 multiplied by 20 means 200. So rect1 dot area will return 200. So in same way we have Rust. So only difference is in Rust we have a self keyword in place of this keyword, and in Rust we have everything and every logic and function declaration defined in class. But in Rust we have function declaration in another separate block called impl. Impl stands for implementation. So for implementation of contract we have to define it inside the impl block. And now as you can see, we are calling rect1 dot area. So here self dot width and self dot height means self means it refers to the object on which this area method has been called. So area method has been called on rect1. So rect1 dot area means rect1 dot width multiplied by rect1 dot height. So here rect1's width is 10 and rect1's height is 20. That will be passed here. So it's similar to JavaScript. Moving forward. Okay, so now comes the four main pillar of the Rust programming language, which is not there in any another programming languages. So that are ownership, borrowing, referencing, and moving. So let me explain you that all things one by one. Yeah, so coming to the ownership first, as we have discussed that Rust manages memory differently. So how Rust manages memory differently is each value has a single owner. So Rust works on a single owner principle where so when ownership moves, old variable becomes invalid. So means when variable an owner of the variable goes out of the scopes, memory is freed. Means let me explain you what do I mean by it. So for an example, I have created one string here called Rust and passed that Rust string to S1. So for if now I am passing that S1 string to new variable called S2, then as you can see ownership has been moved. So now here S1 variable holds the ownership of Rust variable, but now S1's ownership has been passed to S2. So means S1 is now freed from the memory. S1 is not holding the Rust anyhow in the memory, and now S2 holds the ownership of S1. Means S2 holds the ownership of this Rust variable. So this is how the ownership concept is there in Rust. So we also have the referencing concept, immutable and mutable reference, where immutable reference means read only and mutable reference means change the value but only once time. So yeah, moving forward. So yeah, ownership is a set of rules that governs how a Rust program manages memory. So all programs have managed the way they use computer's memory while running. For example, some languages like Java has garbage collection that looks if memory is no longer used, right? But Rust manages it differently using ownership. So let me give you an example again. So for an example, here we have declared a string called hello s1 and passed that value s1 to s2. So what happened here is first hello's ownership was there with s1, but now hello's ownership has been transferred to s2 and s1 will be freed from memory. So now s1 variable is not there in the memory. So if you are trying to print the s1, then the program will give an error. In Rust, error are called panic. The program will panic, means program will return an error because s1 is freed from the memory, because s1's ownership has been transferred to s2 and now s1 does not have any ownership, so it will be get freed from the memory. Okay, so now s2 holds the ownership of hello string value, and s1 will get freed from the memory. So that, if you are trying to print s1, then you will get an error. But here here the scenario is different. For example, if you have created a variable and passed the value 5 to it, and then if you are trying to pass the value 5 to another variable y, and then if you are trying to print x, then it won't panic. Why? I will explain you in deep why this program don't give an error and why this gives an error. Okay, because ownership concept is different for both variables which are using the different memory. So there are two types of memory in any computer system. So stack memory and heap memory. Okay, so if at the compile time a program or compiler does not know that how much bigger a variable's value can be, then it will be stored in the heap memory. For example, for the string here hello, we do not know that which value can be there in s1 variable, because s1 variable have value string hello, but here I can also write hello world, hello anything, hello how are you, means this can be any long, this can be a single word also, like h, like m, like s, means we do not know at the compile time that how long the value of this string is, right? But here we have value 5, And what we have learned earlier, integer will have fixed value with bit called, if we have u8, 8 means 8 bit, 8 bit means 0 to 255, means at the compile time we know if the variables type is u8, then it can only hold the numbers range from 0 to 255. It cannot have any number out of that range, right? But here in the string case, we cannot know what is the value of the string. It can be anything. Hello, how are you, or happy coding, it can be anything, right? So that's why the strings are stored on heap memory, right? So if the strings are stored on heap memory, and here this is the integer value, right? So this is at the current compile time we know how long a number can be, right? So that is stored on the stack memory, right? And then if any variable is stored on the heap memory, then the ownership will be different, and if any variable are stored on the stack memory, then the ownership will be different. Getting it? So the variables which are stored on the heap memory, if we are transferring the ownership, then that will be removed from the memory. S1 is freed from the memory. But here variable are stored on the stack memory. So if you are transferring the value 5, then it will not get freed from the memory. Why? Because this is stored on the stack memory. Why? Because 5 has, we know at the compile time that this is the integer value. For example, we have defined the variable let x colon u8. u8 means this value can be in range of 0 to 255, and here 5 is in the range of 0 to 255, right? This is the positive number, right? So that's why this will be stored on the stack memory and string will be stored on the heap memory, and that's why the ownership will handle differently in both of the case. We have got an idea of what is the difference between stack memory and heap memory. Let me give you a more introduction of what is the meaning of stack memory and heap memory. So in the stack memory, the data are putting in the LIFO manner, last in first out, but in heap memory there is one allocator which is allocating the memory for you. So for an example, if you want to store the hello, then the allocator will find that in the heap memory it will try to find the enough space first to store the hello. So this process is called allocating. So allocate, for example, in the restaurant, if you are going in any restaurant, then the person who is standing there will ask you how many people are there in your group. Then it will find the table on which you all guys can sit. So finding a free space and finding an element in heap is harder and time consuming than as compared to stack, because in stack everything got pushed on the top of the last element. Okay, so moving forward, yeah, this is how the string has been stored on the memory. So the length of the string and the capacity of the string are stored on the stack memory. Then the one pointer will be stored on the stack memory, which points to the actual data of the string, which will be stored on the heap memory. Are you getting it? Means the data of hello will be stored like this, HELLO, on the index wise, and the stored data we can get here on the heap memory through this pointer, and this pointer and the length of this string will be stored on the stack memory. So what happens when you do this S1, let S2 is equal to S1. So in memory it will be like this. Another pointer will be created which will be pointing to the same data at which S1 was pointing. So once the S1 goes out of the scope, a drop function is immediately called. So here drop function is called for S1. So now only S2 is holding the this variable with this value called hello, and this thing is called moving, means S1 has been moved to S2. S1's value hello has been moved to S2. Okay. Yeah, so this is how Rust manages it. Okay. So moving forward. Okay, borrowing and referencing. So here we have the concept of referencing. So we have two type of referencing. One is immutable referencing and second is mutable referencing. Immutable means you have read-only access, and immutable means you can change the value but only one mutable reference is allowed at a time. For example, left hand side we have immutable reference. So let's have a look at this. We have the main function. We have declared one string called alias and passed that value to username variable. Then we have passed this string called alias, this username, to this greet function, and then we are printing the username here, and then it is still usable here. Why? Because we have passed this alias to this another function. That still it is usable because we have passed using the ampersand sign. If we have passed this value alias to this greet function without the use of this ampersand sign, then it is the same case as this case. Like we have not used the ampersand. If you want that, if you want like s1 still holds the ownership of this hello variable, and we s2 just wants to borrow the value hello from s1, then we have to use here sign ampersand. So for an example, if we have used here ampersand, then what happen is s1 still holds the ownership of hello value, and s2 has borrowed ownership from s1. So if you are trying to print s1 here after adding ampersand here, then it is a valid code. Why? Because we have used ampersand like here. Let me show you. For example, here we have passed username with ampersand sign. Ampersand means now this greet function can have the value username. The greet function can store the username, and here hello alias will be printed, but username still holds the ownership of alias. Why? Because we have passed the value alias using ampersand sign, means greet functions has borrowed the value alias. It does not have, greet function does not have the ownership of alias, which was not the case here, because here we have directly passed without using ampersand sign. So now s2 holds the ownership of hello has been transferred from s1 to s2 because we have not used ampersand sign here we have used the ampersand sign, right? So now greet function only have borrowed the alias. So now greet function will be able to print the name alias, but it does not have the ownership of alias. Alias ownership is still there with username. So if you are trying to print username, then because username still has the ownership of alias, now it will be usable because we have used ampersand. Here we have not used the ampersand, so s1 won't hold the value hello, but that is not the case here. Getting it? So on the right side we have a mutable reference. So as you can see, if you want that this function add exclamation can change this value high, as we have told that everything in Rust is immutable. So here we have passed greet function has borrowed the value alias. So now it will be able to print alias, but it does not able to change the value alias. So now this function cannot do like hello alias, how are you? This cannot change the value of the alias, right? It can only read it. It cannot add anything to it. But what if we want to add or change to it? Then this is the immutable reference. Then we have to come to mutable reference. So as I told that if you in Rust, if you want to change and mutate anything, then you have to declare the variable first as a mutable, because we want to pass this high to another function, and we want that function could be able to change this value high. So we have to first declare mute variable so that this value high can be changed later on. Okay, so as you can see, we have passed this greeting variable which is holding high to another function called add underscore exclamation with ampersand and mute sign. These both meaning are different. Here ampersand's meaning is also different, and mut keywords meaning is also different. So what is the meaning of ampersand? Means this add underscore exclamation function has borrowed the value of high, so now it can read the value of high, which this add exclamation function can read the value of high, as we have used ampersand. And we have also used mut keyword. Mut means now this function can read also, and then this function add exclamation can change that value high also, because we have passed a mutable reference. So now high exclamation mark. So here what will be printed? High exclamation mark. because we have pushed the exclamation mark at the end of the string. So if we are printing the hi here greeting variable, then hi exclamation mark will be printed. Why? And first of all, why we will be able to print greeting here? Because we have used the ampersand sign here. Ampersand means this greeting still holds the ownership of this hi variable. Here the case was different, because we have not used the ampersand, we can't use s1 anymore here. But here we have used the ampersand, so we can be able to print greeting variable after passing it to another function also, another function add exclamation also. Still the ownership is there with the greeting variable, ownership of hi is there with greeting variable. So here hi will be printed, but we have this function has added exclamation mark at the end, so hi exclamation mark will be printed. Okay, so this is all about borrowing and referencing. I hope you understood this, because this is the main concepts of Rust: ownership, borrowing, and referencing. We have covered all of three. So I hope it makes sense now. And if you face any difficulties to understanding these concepts, then please reach out to us. So moving forward, okay. So in Rust, uh, in the immutable reference case, we can allow multiple variable to borrow the immutable variable. For example, I have created one variable called s1 and passed the value Hercules to it, right? And now I have created two more variable s2 and s3, and now both are borrowing the value Hercules from s1. So are you getting it? Here we have used the ampersand sign. What is the meaning of ampersand sign here? Means s1 still holds the ownership of Hercules here. S2 and S3 only have borrowed Hercules from it. S1's ownership is still there, Hercules' ownership is still there with S1. Because, for example, in the previous two slides, here we have passed the value hello to S2, but we have not used the ampersand, so S1 will be get dropped from the memory, because S1 goes out of the scope. S1's value has been moved to S2. S2 holds the ownership of hello. S1's lost the ownership of hello, because we have transferred, moved S1 to S2, because we have not used the ampersand sign here, right? If you are using the ampersand sign, then you can create multiple variable s2, s3, s4 up to anyhow you want, but make sure to use ampersand sign so that s1 still owns the ownership of s1 of Hercules. So if you are printing s1, s2, s3, all three will print Hercules, and Hercules. Let's comes on the right hand side, mutable reference. So in the mutable reference, if you are creating a mutable string called variable called s, and if you are passing the value hello to that mutable variable s, means the hello value can be changed by any other variable, right? But as you can see here, we have declared two variable r1 and r2. Here we have passed the value hello r1 with ampersand sign, so that r1 can also use hello, means r1 has borrowed this hello from s variable, but it also has permission mute means r1 has borrowed the value from s variable, and it also has permission to change the hello, right? Because mute has been used. But make sure that here you can't do this again. You can only mutate the reference one time only. Here that won't the case, because you can pass the multiple immutable reference, but mutable reference you can only pass one time. You cannot say that yeah, this is the hello value and this can be changed by two variables called r1 and r2. This can't be possible in Rust due to ownership concept, because only one will have the ownership to change it. Hello can be changed by only r1, not r2. Here all were only reading the value, s2 and s3 only reading it, and it was immutable. Here we haven't used mute keyword, and s1 was also haven't declared as mute, but here s has declared using mute keyword. Getting it? Okay, so moving forward. Okay, so as we have seen that in the right hand side on the rust, for example, I have created one variable fname, passed the value meet to it, and then I am trying to pass this meet to this function called print underscore fname without the ampersand sign. So what happened here is we have transferred the ownership of this meet value to this print underscore name function. So now print underscore name function will hold the ownership of this myth, and now this fname is does not have the ownership of this variable, that will go out of the scope. Rust will call drop function, and this variable will be removed from the memory, so that you can't able to print it. As you can see, cannot borrow fname after it has been moved. Fname has been moved to this print underscore name function because we have not used the ampersand sign. It is the similar scenario like this. Here we have passed hello to another variable, and here we have passed value to another function. If we here it was not the case, why? Here it was not the case, why? Here also we have passed alias to another function, but still in the main function we are able to print username. Why? Because we have used the ampersand sign here. Means grid function is only borrowing the alias. Ownership is still there, ownership of alias is still there with username. So that's why we will be able to print the username here, because we have used the ampersand. Ampersand means grid function has borrowed the value of alias, but here we are not doing it. Here we are directly passing it. Means myth valued has of fname has been moved to print underscore name function. So if you are trying to access the myth value of fname variable again from the same function, same scope again, then it will give you an error, because myth's ownership has been moved to this function, print underscore name function. So if you are trying to print myth here from print underscore name function, then it will print it. But here, after you moving, you cannot print it. But that is not the case with JavaScript. For example, if you are JavaScript, you are passing fname variables value meet to another function called print nm, and then if you are trying to print fname again, then it works fine. It will not give you an error, because Rust handles memory differently to avoid null pointer reference and dangling pointer issues. Okay, yeah. So now we have covered ownership, borrowing, referencing, moving, and how Rust manages memory. So moving to the next concepts. So it is operators, loops, and flow control in Rust. So these are the operators in Rust, just like another programming languages, plus, minus, modulo, and everything. And these three are the loop types: loop, while, and for. Make sure that loop is the if you are using the loop keyword, then you have to use the break keyword to break the loop, because loop is infinite loop in Rust, and while is conditional loop, and for loop is the same. While and for loop are the same as another programming languages, right? So as you can see, if we are using the loop, then loop is infinite, so we have to break it at some point. Okay, if n is equal to 3, starting from n is equal to 0, we have used the mute keyword. Means n can be changed, n's value 0 can be changed, because we have used the mute keyword. Inside the loop we are incrementing n at each iteration, and if n reaches to 2, then we are skipping this iteration, we are not doing anything, and once n reaches at 3, we will be breaking this loop, and then this function will be ended. Yeah. Okay, so as we have covered the basics of the Rust programming language, now I will walk you through the basics of stylus. What is stylus and its methods in the smart contract development using Rust programming language. Coming to the modules.xcan.dev. So now as we have covered Web3 basic and Rust fundamentals, so you can come to the Web3 basics modules, and it does have total of six chapters. So these three chapters are of Rust. So please try to complete these chapters based on your understanding. And if you are getting stuck at anywhere, then please try to rewatch the video. Then you will be able to answer the questions which has been placed in these chapters. So in this video we have covered Rust. So in later videos I will walk you through the stylus and stylus SDK part, and then I will explain you the practical stylus foundation challenge. So if you stuck at anywhere, then feel free to reach out to us. Thank you for watching the video.